Okay, question 43. It says the vertices of quadrilateral EFGH are E at negative 7, 3, F at negative 4, 6, G at 5, negative 3, and H at 2, negative 6. What kind of quadrilateral is EFGH? All right. On test day, you will have graph paper. Okay, so you'll be able to plot these points perfectly. I don't have graph paper here, so I'm just going to make a sketch. Okay, so what I would do is I would draw this out. Okay, I would go to negative 7, 1, 2, 3, 4, 5, 6, 7. All right, and then up 3 for my first point. 1, 2, 3. I'm trying to make this as even as possible. So there would be E. Okay, F is at negative 4, 6. So I'll go over 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, and up here. So there would be point F. Okay, then we get to G. G is at 5, negative 3. 1, 2, 3, 4, 5, and down 3. That would be here. And then I have a point at 2, negative 6. So over 2, down 6, which would be here. So let me just put these points in. That was at 6. This is negative 6 down here. So 1, 2, 3, 4, 5, 6, and over 2, there would be my point. All right, so 2, negative 6. So this is H, this is G. Now looking at it, it kind of looks like it's going to be a rectangle, but we're not positive yet. Here's one we can do this. If you have the coordinates, negative 7, 3, and negative 4, 6, you can figure out basically what you have to do to get from E to F. Okay, so to get from E to F, we have to go over from negative 7 to negative 4 in the x direction. So from negative 7 to negative 4, that's a distance of 3 in the x direction. And we go up from 3 to 6, which is also a distance of 3. Okay? Now let's see how that matches up with what we did over here. H had coordinates of 2, negative 6, and G had coordinates of 5, negative 3. So to see how this pattern is, to get from 2 to 5 in the x direction, you've got to go this way 3, and to get from negative 6 to negative 3, you also have to go up 3. So both of these have a slope that goes up 3 and over 3, up 3 and over 3, okay? So that means these two lines, since they have the same slope, are parallel. All right, so now let's just see if these are parallel right here. So to do that, we need to figure out how we get from negative 4, 6 to 5, negative 3. To get from negative 4, okay, and actually let me use a different color here. Let me back up for just a second. Let me use red here. So let's say we want to know how we get from negative 4 to positive 5. Well, we do 5 minus negative 4. 5 minus negative 4, whoops, is the same thing as 5 plus 4, which is just 9. So that means we are going over a distance of 9 in the x direction. And now we just want to see how far we go down. Okay? Well, we start at 6 and we're going down to negative 3. 6 minus negative 3 is the same as 6 plus 3, which is also 9. Okay, so that means we're going over 9 and down 9. All right, so that's the slope of this line. Whoops, that wasn't very well drawn, but that is the slope of this line. Now that's supposed to be a straight line, and obviously on your drawing it should be, but over 9, down 9. So if this has the same slope over here, then that means all sides are parallel. Okay, so let's check this out. If we, let me use a different color here again, let me go blue. To get from negative 7 to positive 2, negative 7, actually we're going to use the bigger number, I did that wrong, 2 minus negative 7, the bigger minus the smaller one, and that's the same as 2 plus 7, which is also 9. Okay, so that means we're going over 9 this way, over 9, and to figure out, to get from 3 to negative 6, this y minus this y, 3 minus negative 6, same as 3 plus 6. So this is also going down 9. Okay? So look right here. We have a slope that's going up 3 over 3. All right? That is a slope of positive 1. Rise 3, run 3. Over here, we also have a slope of 1. Same slope means they're parallel. Okay? And if you look at these two, the red and blue lines that we just did, these are going down 9 and over 9. Okay? And even though I put the over side first, that's fine. It doesn't make a difference. But slope is rise over run. So the rise is down 9 over 9. So that is a slope of negative 1. Okay? For this side and for this side. Those are the slopes. Now, these slopes, okay, if you take a slope of one side and you want to know if it's perpendicular, you take the number, you make it a fraction. Well, 1 is just the same as 1 over 1. Okay? You flip that fraction. In this case, it's not going to do anything because if you flip one to the top and one to the bottom, you still get 1 over 1, but you make it negative, okay? So 1 and negative 1 are what we call perpendicular slopes. They are opposite reciprocals of each other. So since these are perpendicular and opposite sides are parallel, it's obvious that these are not the same lengths. E and F, or EF and FG are not the same length. So this is an example of a rectangle that is not a square. So the correct answer here is C, not a trapezoid, it's not a square, and it's not a rhombus because it has right angles. Okay, because the slopes are perpendicular, which tells us these are right angles at the corner. Okay, so the correct answer is C.